Great. Well, good morning, all. As you mentioned, I am attending virtually from the East Coast of the USA, so it's about 7 p.m. at night, not too late. And I actually have a newborn in the house, which is some of the reason I wasn't able to travel out. So please pardon any background noise. But it's a real pleasure to be with you, and I look forward to attending in person in the future. A little bit of background about myself. I actually come from the fire service, which is some of the FSRI's work. And so I know from attending some of yesterday's sessions that there are a fair amount of fire service folks in the room. And coming from a volunteer fire department where we were a combination, in the same station, responding to the same fire as career folks, and my trajectory into some academic, undergraduate and master's work, and then into the professional world where my research is focused on WUI, wildland urban interface fires. I find a lot of connection with some of the stories that I heard yesterday, and I hope that some of the information that I'll share today is relatable. And really, the motivation for submitting this presentation and participating in this conference is to open lines of dialogue internationally across borders, with the work that you folks are doing down there in Australia, with the work that we're doing here in the US and other parts of the world. We have colleagues in Canada and Europe, to recognize that, as many of us know, whether you call it wildland fire or bushfire, it is truly a global phenomenon. What you like to say in fire research, fire only needs fuel, oxygen, and heat, and if you give it all three of those things, it'll burn fine, and geographic and spatial locations has an effect, but that's something that unites us all. So I'm going to go here and share my screen. I do have some slides for the presentation today. And also I'll just mention that while I would have loved to be there in person and connect with you all, I have my contact information. Please do reach out. I will be on the virtual app to attend future sessions and network with others. But really the intent here is to both share some information and knowledge of what we're currently working on, and find opportunities to continue working together in the future and share knowledge going forward. So with that, I'll get jumped into my presentation here. Again, I think I need no more introduction of the title of the presentation, and I'll jump right into a little bit about the content, which is, for those of you that may not be familiar, what is UL? UL is a stamp here in the US. I don't know the Australian equivalent. I should have looked that up. But UL has a history going back to 1893 when the World's Fair was in Chicago in USA. This is a photograph from setting up from that, and a recent graduate from MIT, Massachusetts Institute of Technology and Electrical Engineering, William Henry Merrill, his first job after graduating was actually to go and inspect and to oversee the construction process in preparation for the World's Fair. And as part of doing that, he had conversations with underwriters and other insurance industry folks. And if you kind of know the history of engineering in that time frame, the electricity was a boom and we had all these machines and capabilities, yet they also created some hazards, some new hazards, and we didn't have a consistent way of evaluating the hazards and the safety of different devices. So one of the things that Henry proposed during his time at the World's Fair was there should be a laboratory that can develop and conduct standardized tests, so that way when new devices and new engineering designs are developed, they can be evaluated for their safety features. And a year later, in 1894, Henry did just that. He founded what at that time was Underwriters Electrical Bureau, and later known as the Electrical Bureau of National Board of Fire Underwriters. That UL has gone through lots of different names. I think, again, in the US and probably internationally, most known for the UL symbol. But another thing to note is that Henry William Merrill had a strong connection with the fire service, which is what I'll be talking about today. Some of his first lab space was actually in the hay bale or the hay barn above one of the Chicago fire departments. Probably not necessarily fire safe to be doing electrical experiments in a barn with hay, but the roots of UL and Underwriters Laboratory with the fire service go very deep. Fast forward a little bit to present day, and just to give a little bit of sense of, that UL letter with the circle around it. The organization has evolved a bit, and again, just for the sake of the context of what I'll be talking about today, there are not now three separate organizations. UL Solutions is the for-profit, which I think most people are familiar with back from the 1890s, where they provide services of testing and inspecting and listing different products to the standards. UL Standards and Engagement, that's in the green circle there. They are a non-for-profit arm that does some work with regulators and governments to help them understand what their challenges are and where UL tests need to be developed and are developed to help them. And then UL Research Institutes in the blue, which is the organization that I work for, where we conduct the safety science, the research, the understanding to inform both UL Standards and Engagement as well as other standards development organizations, and UL Solutions as well as other testing labs, and how we can and should be doing this research, all kind of that centerpiece there towards safety science. And then one more layer deep, just a little bit of background, is within the UL Research Institute is the organization I work for, that is FSRI, the Fire Safety Research Institute. Amongst others, we have a material research institute and an electrochemical, think lithium-ion batteries research institutes, two different institutes working on different safety problems. But at FSRI, our work is dedicated to addressing the world's unresolved fire safety risks and emerging dangers. This is a photograph from probably the past decade or so where a lot of our historic research has looked at fire dynamics in a structure, and what firefighters can do, whether it be apply water suppression, ventilation, the evolution of construction of buildings and the fuels inside of it, and how that all interrelates. But that's kind of, that's our bread and butter, so to speak. But there are so many other fire risk and emerging dangers, which is part of the work that I do, is looking at fire. I think of it outside the box. You see the flames coming out of the door there, but what about flames that don't originate inside a building and come out? What about flames and embers and fire outside the building that impacts it, like during a wildland or a brush fire? And then I guess one more here, FSRI is an acronym. Originally in 2013, we were the Firefighter Safety Research Institute. So again, a long history. Many of the researchers come from the fire service background. And in 2021, a little bit of a rebranding there with our new logo that I'm wearing on my shirt here. The Fire Safety Research Institute to branch out from more than just what firefighters need, although that is still one of our key stakeholders, but also the fire safety ecosystem as a whole. So with that as a little bit of background, this is a clip. This is just an image, and there is a video, and I know I'll have the opportunity to share, I think, at least a PDF version of these slides. So I'll include a link to this video. But this is a video taken from the dash cam, and for the first responders in the room, this might look all too familiar. This is taken from LA County in Southern California during the Woolsey fire. And in fact, during the interview, during the video, there are two firefighters that were actually in this vehicle talking about what they were seeing. And this is just a clip, but they're driving down the road. They describe these balls of orange, and that's the bushes and the trees on fire. They describe the flurry, the storm of firebrands or embers. You see them in the sky, and you see them on the ground. And again, for many of us here at this conference, I imagine this is all too familiar image, but for some folks that don't live near a wildland or a bushland interface, or may not have any fire experience before, this can be kind of eye-opening. And you might see this on the evening news, but beyond just understanding what is happening inside of these events, this video and this clip kind of gives us really that eye inside the incident to understand what is going on from a fire behavior, from a fire dynamics, from a fire phenomena. And I mentioned it there. We have the flames from the burning fuel, in this case mostly vegetative, but also some structurals. We have what looks like a wooden fence or a utility pole there. We have wind that's driving those embers, and you can hear it in the video, not see it so much in this still frame. And you also see the embers or the firebrand, those particles that lead to a lot of the ignitions in and around homes. So, again, I think for this audience, this is a bit redundant and people can relate to it. But if you weren't familiar, we have a lot of the same scenes that you all experience and see down in Australia here in parts of the US. And then just a little bit about to talk about some of the recent history of wildland urban fire disasters in the US. And I imagine, many of these incidents were large enough. I'm familiar with the Black Sunday fire or the Black Summer fires in Australia, so you're likely familiar with these as well. But just to give a little bit of context, in 2017, we had several fires in California, one of which in Northern California, in Sonoma and Napa, where we have a lot of good wine, was the Tubbs fire. And on the left-hand side of this slide, you see the total fire perimeter, and the orange dots are actually structures. And then we see in one of these communities in particular, Santa Rosa, which is actually a city, and how we break up jurisdictions here in the US may be similar to how you break it up in Australia, but you typically don't think about the wildland urban fire risk in a city, yet in this community, in the city of Santa Rosa and Coffey Park, you can see all of those orange dots. Nearly all of the homes in that section of the community were completely destroyed by the fire. Some of them were damaged and not destroyed. But the reason to bring this up is to recognize what, we, at least here in the US, used to think of, oh, this is a suburban neighborhood. Yes, it has some green trees, but that's not a wildland risk. That's not a wildland fire risk. Well, the reality is when those ignition mechanisms can travel, over 8-lane highways and travel into these communities and transition from a wildland urban fire to an urban conflagration, the result can be this devastation. And unfortunately, these destructive photos and experiences are motivation that we need, although we shouldn't, to understand how and why. And so again, in the spirit of safety science, move forward to reduce and then in best case, totally eliminate. One more example I'll offer here, and when I was going to be there in person, I was going to actually co-present with one of my kind of research colleagues based in Australia. He is at I forget the university now, CSU, and he was going to give some examples of examples of fires in Australia. But one more example from the US, a little bit more recent, the end of 2021 going into 2022 last year in Boulder, Colorado, the Marshall Fire. And again, just, to show images for the sake of making the example or making the point very clear, is that when these natural phenomena, the wildland fire, burn into urban communities, they can cause severe and disastrous destruction. And so this is the motivation at FSRI for us to try and apply our knowledge of fire phenomena, heat transfer, and material properties and ignition, what we know about fire dynamics and fire behavior inside of a box, and apply that to help move the safety science forward for these exterior and outdoor fires. So again, in the spirit of kind of just giving a high-level overview, I'm going to talk about some of the projects that we're currently working on here. This is not intended to be an all-encompassing presentation to go in depth, although there's one project that I will, but really in the spirit of to make some awareness of the kind of work that we're doing. Again, in the PDF slides, we'll provide links to these project page where you can get updates. And I really hope that you'll reach out and we'll find opportunities to collaborate on these and other projects in the future. So one of the projects, and this is very close to the history of FSRI in the firefighter space, is firefighter PPE, or firefighter personal protective equipment. One of the big challenges here in the US is that many urban or city departments also respond to brush fires or outdoor fires, and there is this kind of coincidence, they coincide, where urban departments or suburban departments and homes are, and where fires start is that kind of that coinciding of where destruction can happen. And for those of you that do or might respond to some structural firefighting bunker gear, that's whatever the statistic is, 80 pounds, and to convert that to kilograms of gear that, a firefighter would need to wear to go inside of a house to protect them so they can do the tasks and duties that they need to. But when operating outside in the heat and over longer distances, that PPE just doesn't relate. And so one of the challenges or opportunities that we have in the US is to not to learn our lessons from structural PPE and apply that to wildland or WUI PPE and recognize there's overlap there. So, typical Nomex lighter weight materials might be more breathable and easier for firefighters as they're fighting out in the brush and in the forest. But as they start doing structural protection into communities, they might need more. And then one of the big projects is on respiratory protection. We know that respiratory cancer and respiratory illnesses is a leading cause of injuries and fatalities to firefighters. And one of the challenges for wildland firefighting is you're often exerting so much effort over a long period of time, we don't have respiratory protection. And so some of our projects here to help and to apply knowledge, apply science, and understand the needs to make firefighters safer in those environments. Another project that I'll talk more about, so I'll just go briefly here, is structure-to-structure heat transfer. The idea of that urban conflagration, whether it be Coffee Park or whether it be the Marshall Fire or whether it be a fire down in Australia, when we transition from primarily vegetative fuels to structural fuels, those fuels burn differently. They're made of different materials, and so they have different heat releases, and the fire spread from one bush to another bush is different than the fire spread from one building to another. And so we have a pretty in-depth study to look at fire spread from building to building, looking at things like fuels in between them, in this case a PT Cruiser, which again, it's unfortunate I'm not able to show that video there. That's always a good one to see a PT Cruiser burn, but really this kind of gets to understanding fire behavior, fire dynamics within an urban or suburban setting, which is oftentimes is associated with the wildland urban disasters. And I talked about in that video, and I kind of interchange terminology here, but the embers or the firebrands here being a pile of them, the heat transfer from those. And so in a former life, I did a lot of work on individual structure vulnerability to the different ignition mechanisms. And we found that the primary mode of building or structure ignition, at least here in the US, was due to firebrands or embers. And that was either directly they land on something combustible and ignited, or indirectly they land on something combustible near the home, which subsequently burns and ignites the home. And so we're doing work to understand how do we, in the kind of the same spirit of the origins of UL, create and develop a standard test maybe for evaluating different materials. Right now, this is a pile of wood dowels that are ignited over a burner and placed on top of material. But what about the effects of wind? What about if you had a larger pile? In the video, if we had seen it, you saw some instances of firebrands accumulating that creates this pile here, but 2-3 seconds later, a gust of wind blows that pile away. And so that very dynamic situation is going to affect how the materials respond, which ultimately is what we're trying to get at is, what is the threat, what is the exposure that firebrands pose, so that we can develop materials, design buildings, and design communities to be more resilient to these exposures. And then a little bit beyond just kind of the thermal effects are the secondary effects. And again, these are two photographs that you've seen already after fires that pass through. And so what about post-fire? And so this is a project where we're looking at the water contamination from WUI fires. And this photograph here is actually from an experiment. It was from an experiment inside of an enclosure. But what we do for some of that research is actually collect the gases, and we want to know what the CO levels and CO2 levels are. In order to do that, we have to cool the gases down. Pardon me. So this is what we call a gas trap, and kind of unbeknownst to us, we were, emptying these out and asked the question, well, if this is coming off from a structure fire, this is coming off from however many of those structures, whether, how many of those structures burned in the wildland fire or the wildland urban fire. and generated these same types of contaminants. And I can tell you that that stuff coming out of there is not good. We're wearing gloves and eye protection and face masks for a good reason. And so, not only what are the thermal effects of the fire, but what are the secondary effects? And so some of the challenges that we've seen is underground utility pipes might be made of, materials that decompose from the heat, and that might be contaminating our water supply. Or these fires burn out these homes and then rains come, and that all that runoff has all of these nasty materials in it. And then a non research project item that we're working on is our Wildland Urban Interface Advisory Committee. This is made up of folks from the research community, from the fire service community. We have a fire marshal from the state of Colorado where the Marshall fire happened. And again, I did just want to mention my Cobra Center, Greg Penny, is our international connection down in Australia, which is kind of some of the motivation for wanting to be engaged with this community at this conference. I am going to talk a little bit more about one of these projects, although I do want to be mindful of the time and leave some for questions at the end there. But highlighting here the firebrand heat transfer and the structure-to-structure heat transfer. And I'm actually going to skip ahead real quick just to talk about the structure-to-structure heat transfer, because there is a presentation later today that relates to some ongoing research that's going to be happening in the next few weeks. So very quickly, a summary of what you're seeing here in this picture. We have a post flashover compartment. That's what the flames are coming out of. So you can imagine in a suburban community, this might be a sliding glass door behind or on the side of a house. And that target facade where you see the back of is the neighboring structure. That distance is about 2 meters away. And what we're actually evaluating in this experiment, these experiments that occurred last year, was for different window glass types. So what we call annealed or plate glass and tempered, which I think is similar to your toughened glass, is, if you have dual panes, does it matter is the outer pane tempered or the outer pane annealed, or both panes tempered or both panes annealed? And so this is kind of an array of different windows with different orientations of glass. We're also measuring on the surface of that wall the heat flux. So we're measuring the order of 90 to 100 kilowatts per meter squared. So those windows are getting exposed to pretty significantly, as well as the heat flux on the backside. And this is all part of understanding that specific building component, the window, and how it might be vulnerable. How this relates to a presentation later today, some upcoming research building on this is, well, what if you had a protection mechanism like a shutter or a screen, or if firefighters were doing structural protection and they had some time to prepare around the window, could they put something up? And I know it's more common there in Australia. And in fact, we worked with one of the companies down there to get some of their product, but metal shutters or, again, screens. And so that's a tie-in for some of our current research, and I'm looking forward to that presentation later today to learn about some of that work that's being done down there. And just to wrap it up here with the last few slides, to talk about the output of FSRI research, again, from our firefighter safety origins, a lot of tactical considerations. So this might relate to whether you should vertically ventilate or how you manipulate a hose. But we very much envision that this will apply to wild and urban as well, from the PPE to the hose tactics to structure protection. Another part of this is science to the street, and to the bottom right-hand side here is a prop that we built and provide the plans for others to build so they can practice how to manipulate a hose and how it creates different inlet flows and entrainment air inside of a structure. So again, that's kind of the application of science to where others can do their own hands-on training. We do publish reports as well as peer review publications, as well as databases. So I imagine there might be some questions about some of the research that I showed. I'll have links on the next few slides, but nearly all of our research, because of the organization that we work for, we're not-for-profit, we are fortunately self-funded, it's not proprietary. So we publish in peer review, we nearly always publish open access, and when we publish papers on research, we always attempt to also publish the data that goes along with it to not just share our takeaways, but the opportunity for others to do the same, which gets into one of the last items here, research amplification, campaigns like Close Before You Doze. If you're not aware of this, internal compartment fires, open doors create pathways for that fire to spread. And so in the US, we have smoke alarms, and people thought, oh, I couldn't hear the smoke alarm on the other side of it. But in fact, you can hear the smoke alarm just fine. And the difference between closing your bedroom door and if there was a fire, say in the kitchen, living room, or in one bedroom passing to another, a closed door can make such a big difference. So those kinds of educational campaigns. I am going to just skip through this last slide real quick. It's just an overlay of 2 fires to show some history there. And I'm going to jump to my last slide here as promised with some contact information for both myself and some of our social medias, and where you can see some of the pictures and videos. And I hope there are questions. Again, apologies that I'm not able to be there in person, but I look very much forward to connecting with you all here today and going forward. So thank you for your attention. Thank you for your time. And I appreciate you.
Thanks so much for that, Daniel. So we do have, do we have the questions? No, we haven't got, are there any questions in the room? Oh, yes, we do. Do you want to wait for a microphone, because then the speaker can actually hear you? So just hold on a sec. It's a big room.
Thanks for the presentation. Have you identified the parameters for mapping risk inside the urban perimeter?
Good question. I think we have a sense for what those parameters are, and my personal opinion is what we know of those parameters and how dynamic that they are. It is very challenging to do a mapping exercise. Things that matter include the ignitability of any one structure, which is a function of the materials built with and the construction details and what's around it. And then a community is some of, with an additional factor of the vulnerability of all the structures in their proximity to each other, as well as wildland risk. So I guess that's a kind of cop-out answer to your question. I think we have a sense of, individual building vulnerabilities and at a community scale, but one of the challenges that I see is how dynamic those factors and parameters are to then do an exercise of whether it's a mapping, you can forecast what the wind, you can look at the historic winds and forecast on what they might be, but there might be instances in between those brackets that you put up there that doesn't fully capture the risk.
Are there any other questions from the room? Well, while people are thinking of some, I have some questions. Given you're based in the US and you're working with partners in Australia, I'm wondering if you see any key differences between Australia and the US in terms of our approach to reducing fire risk in buildings, like that kind of close before you doze. I don't know that we have an equivalent campaign, but particularly around the kind of regulatory frameworks that operate there and here.
Yeah, and this is actually a topic that I'm learning more about in Australia. So I can speak to what I know in the US, which I'm actually quite familiar with, and what I know of Australia, and maybe we can identify the differences. And that is, in the US, we do have kind of a top-down structure where at the state level, a state adopts a code, and then at the jurisdictions below it, those jurisdictions can't have anything less stringent, but they can have things more stringent. All that goes to say is we have kind of quite the range. And one of the other challenges is we have a long history of regulations and codes for interior building fires, and we have tests and knowledge and prescriptive-based approach. We don't have much of a performance-based approach tolerance here in the US, although we're hoping to get more of that. And in the case of exterior fires or wildland urban fires or bush urban fires, we do have a lack of knowledge, so we then have a lack of prescriptive code requirements, and so we have a lack of adoption of it. So we're just a little bit behind the 8 ball. That's the status here in the US. I know in Australia, you have 3959, and we have some equivalent codes in the US. I think one of the key differences that I appreciate about the Australian model is you have a deemed to satisfy. I know that's one of the presentations from yesterday, but also a higher tolerance performance based. And that's something that we just don't have in the US. And that's a challenge because prescriptive can be too stringent as a coverall, and then so communities, jurisdictions at state level are reluctant to adopt it, and so we then don't have adoption.
We have a question. Yes, go ahead.
Hello, it's Rod here, Daniel. I'm here with James Greer from Wildfire Defence Mesh, and I think you're doing some testing of the product next week at your facility, so thank you for that.
Yeah.
So my question is really about how is it that we can then get common standards across the world, because, you know, it does set up a whole lot of barriers to say, well, we only meet this standard, and you've then got to get it standard in another country, and then you go through a whole rigmarole. How is it that UL can then help in terms of standardising testing over?
Yeah, no, great question. And in a former life, I worked at a standards development organization. I used to work at NFPA, and I think that's a great point. I don't have the answer to it. You know, I think that there are kind of higher levels, maybe the system is what it is, but I can speak to your question about what is ULRI or FSRI specifically doing. And we engage both here in our domestic ASTM, NFPA standards development, as well as at the ISO, the international standards level. And so to your specific question, where there are opportunities that you're doing your standards development in Australia, and we can, you know, share information and share knowledge, that is an opportunity that's always a desired output of FSRI research. So it doesn't necessarily answer your question of how do we harmonize. I think that's the language that we use here. So you don't have three different ones, but at a minimum, we should get to a point where no one standards development organizations or standards development body is behind because they don't have the knowledge, the information from research to inform to make those standards better. And so that is, at least at this point, what we can do. And maybe with enough effort, with enough collaboration, we can get to that harmonization.
Thank you.
Did we have a question? Oh, hang on, we'll just wait for the microphone, sorry. We need hold music. Okay.
Daniel, thank you for your presentation. You said that you're sort of lagging a little behind on the urban interface understanding of bushfire attack levels. Is that because you've seen an increase on that happening into, you know, urban environment, or is urban sprawl? Well, yeah.
Yeah, no, that's a great question. And I'll give my personal opinion here with the caveat that, you know, I don't speak for others. I think in the U.S., in California, you know, has kind of the most pronounced history of wildland urban fire disasters. And so they have a state level code. We talked about Chapter 7A. And I think one of the challenges in the U.S. is that has existed. And so that now becomes the thing that you compare others to. And while Chapter 7A at its time was better than nothing, it doesn't really allow for the different exposures. One of the things I love about the Australian model is the BAL levels, that you account for different, you know, 12.5 up to 40 up to FAL. That idea that you would expect different exposures and the requirement for the building should be based on that different exposure. We don't even have that concept currently here in the US. And so there is kind of a just, you will get all of the exposure. And so you need to be, it's binary. You either need to do all of it or none of it. And I think that's an example. To your point, you know, I don't think that's from a lack of experience. I think some of that is the way it has been done, and there's some momentum, and it's harder to change things that have been going on for so long.
Okay, have we got any other questions from the floor? There aren't any in the app. Okay, well look, thank you so much, Daniel, for joining us in the evening, your time, and sharing us your experiences in the US. I really, really appreciate it. So please join me in thank you, Daniel.
Thank you.
So I am now delighted to welcome